Hypercard is a programming language that was created in 1990 by Apple Computer Inc. Hypercard was designed to be easy to learn and use, so that anyone could create their own programs without having to know how to code. The language itself is a hybrid of several languages such as C, Pascal, and Modula 2. It includes features from object-oriented programming and was also influenced by the earlier hypertext programming language. The goal with Hypercard was to make it possible for non-programmers to create programs by simply dragging icons around on the screen. This approach worked well for simple programs, but became more difficult when trying to create more complex applications. In addition, the virtual machine that ran Hypercard programs was slow compared to native code, and this made it even harder to write complex programs. Another problem with Hypercard was its lack of third-party support, since Apple was hoping that most programs would be created by non-programmers. They didn't invest much effort into developing tools that would help programmers develop programs more easily. This meant that if you wanted to do something that had been done before, you probably had to reinvent the wheel yourself, because there weren't any libraries of reusable components available. In spite of these problems, Hypercard did have some success. One notable example is the game SimCity 2000, which was originally written in Hypercard. However, the language never really took off, and eventually, Apple gave up on it. So why should you care? Well, in my opinion, understanding how Hypercard failed can help us avoid making the same mistakes today. We've seen similar attempts to create no-code development environments before, such as Visual Basic and more recently Scratch. These environments are great for teaching programming to kids or for creating simple applications, but they have their limitations. When you need more power than these environments can provide, you often have to resort to writing code anyway. In addition, even if you don't plan on writing code yourself, it's still helpful to understand how things work under the hood. Otherwise, you might end up getting burned by a language that seems too good to be true. If you want to try out Hypercard for yourself, you're in luck. There's a free and open source emulator called Hummingbird available for Mac OS X and Windows. You can download it from SourceForge at the link below. If you find that the virtual machine is too slow for your taste, you can also run it inside a virtual machine like vMachine. I've also included a link to an article that describes how to do this. Now let's get back to our regularly scheduled program. Next, we have Revolution, which is also based on the Hypercard language. Revolution was created by a company called Mindscape, which was founded by two former Apple employees who had worked on Hypercard. The goal with Revolution was to create a more powerful and flexible version of Hypercard. Unlike Hypercard, which used an interpreter, Revolution compiled to machine code. This made it much faster while still being easy enough to use for non-programmers. Revolution also introduced the concept of a stack, which allowed multiple windows and applications to be active at once. This was a major departure from Hypercard, which only allowed one application to be active at a time. Unfortunately, despite these improvements, Revolution never really took off either. One reason for this is that the virtual machine that it used was still relatively slow compared to native applications. In addition, the language itself was somewhat awkward to use for complex programs. Despite its shortcomings, Revolution did have some success. One notable example is the game Star Trek, which was ported to Revolution from another programming language called. However, like Hypercard before it, Revolution was eventually abandoned. Finally, we come to Livecode, which is a programming language that was created by a developer named Matt Ryer. Like Revolution, Livecode is also based on the Hypercard language, but it is much more than just an improved version of Livecode introduced the concept of messages, which allowed objects to communicate with each other without having to be physically connected. This made it much easier to create complex programs by allowing you to break them down into smaller pieces that could be reused throughout the application. Livecode also introduced a new syntax which was much more concise and easier to read than the original Hypercard syntax. In addition, Livecode added support for multiple inheritance, polymorphism, and other object-oriented features. All of these changes made it much easier to create sophisticated programs. Unlike Hypercard and Revolution, Livecode is still actively maintained and developed. One reason for this is that the virtual machine that it uses is very fast. In fact, Livecode programs can run natively on many platforms without any performance loss. In addition, the language itself has been steadily improved over the years. For example, version 7 of the language introduced support for asynchronous programming. Another reason for Livecode's longevity is that it has a large and active community of users. There are dozens of books and tutorials available on the language. And there is a vibrant community of developers who are always willing to help out newcomers. So what does Livecode look like? Let's start with a simple example. The following code will display the text, "Hello World." The prompt command displays an alert box with the text button clicked. This is just a very basic example, but it should give you a taste of what Livecode is like. If you want to learn more, there are plenty of resources available online. I've been working on a tutorial series for a while now, but I haven't had a chance to finish it. I may post it on a website once it's done, so be sure to check back periodically to see if it's ready. Thanks for watching, and I'll see you next time. Now, here are some more programming examples. This is a program that simulates the classic game Pong. The ball object moves around the screen and bounces off the walls. If the ball hits the paddle, it changes direction. The player can control the paddle with the arrow keys. Here is another program that simulates the game Breakout. The player controls the paddle at the bottom of the screen and must use it to hit the ball and break the bricks above. If the ball hits a brick, it changes direction. If the ball hits the ground, the game ends. Here's a program that demonstrates the use of animation. The square object moves across the screen and changes color every 10 milliseconds. This creates an animation effect. Here is a program that shows how to use sounds in a Livecode program. The triangle button plays a sound when clicked. The sound continues to play until the stop button is clicked. These are just a few examples of what can be done with Livecode. With its powerful features and ease of use, Livecode is a great choice for creating games and other interactive applications. If you enjoyed this video, please consider subscribing to the channel. Thanks for watching.